Next, we're going to look at the graphs of reciprocal trig functions. So y equals cosecant of x, y equals secant of x, and y equals cotangent of x. And remember that reciprocal trig functions are just flipping the original trig function. So in number 7, we're going to graph y equals cosecant of x on the interval negative 2 pi to positive 2 pi. And remember that cosecant of x, when you go to your calculator, is just the reciprocal of sine of x. So we're going to graph 1 over sine of x. Unfortunately, we don't have a button for reciprocal trig. So we're going to graph it from negative 2 pi to positive 2 pi. And when we graph it, it's going to look quite a bit different than the sine curve. So we notice that it reaches these little peaks and valleys. So it has a low point right here, and then over here, and then it has a little local maximum here and here. It looks like there's nothing between the curves here. So something weird is happening here. And what's happening is that when you graph the reciprocal trig functions, you're introducing division into the problem. So think about with rational functions or when you have division involved, remember that we cannot divide by 0. So what's happening is when you have 0 in the denominator, we get undefined. So when the denominator, in this case sine of x, equals 0, we end up with an undefined function. So if I were to graph y equals sine of x into y2, you're going to love this, what happens, and I'm going to make it so it comes in a little thicker. Notice how the curves kind of touch each other. So that sounds kind of weird to say that, but over here, when you get a y value of 1 on the sine curve, well, when you flip 1 or take the reciprocal of 1, you end up with 1. So they have those points in common. Here, over here, when the height of the curve is 1, negative 1, 1, negative 1, they end up being equal to each other. So where does that happen? Where are they equal to each other? Well, this is why I make the window, the x scale, to be pi over 2, because every tick mark is worth pi over 2. So right here is pi over 2. So at 90 degrees, or pi over 2 radians, remember that the sine of 90 degrees, or pi over 2 radians, is 1. So when you flip it, you get 1. At 270 degrees, the sine is negative 1. So when you flip that, you get negative 1. So what's happening when you get 0 for the sine curve? So notice that here, 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 and here, and actually over here also, you get 0 for the sine curve. Well, that is where your function is undefined for the cosecant. So for example, at 0 degrees, the sine of 0 is 0. So when you evaluate the cosecant of 0 degrees, you're actually evaluating 1 divided by 0, which is undefined. So what happens is you end up with vertical asymptotes. So where are the asymptotes? Well, there's going to be one at negative 2 pi, at negative 1 pi, at 0, 1 pi, and 2 pi. So if we were to list those all out, those are where the asymptotes are. X equals negative 2 pi, negative 1 pi, 0 pi, and pi over 2. So what values, so that's just on this interval. But notice we get a pattern going here. So just in general, remember, if you were to keep on going with the curve and you didn't restrict the domain at all, that curve is going to keep on repeating itself, just like I do. It keeps on repeating itself. So what values just in general are restricted from the domain of y equals cosecant of x? So you have negative 2 pi, negative 1 pi, 0 pi, 1 pi, 2 pi, while theta, or x, could equal n times pi, where n is any integer. So 3 pi, 4 pi, 5 pi, 6 pi, those would all be restricted from the domain or vertical asymptotes. And then what is the range of the cosecant of theta? Well, going back to the calculator, the cosecant, remember, was the thinner graph. The highest, so it comes up and reaches a little local maximum right here. So it stops there at negative 1, and then it starts again at positive 1. So negative infinity to negative 1, and then union 1 to infinity. So your cosecant function is undefined at the asymptotes, and the range, there's no y value that occurs between negative 1 and positive 1. And if you substitute a few values in, so for example, at say 30 degrees, what's happening is the sine of 30 is 1/2, but when you flip that, you get 2. So because the range of the original goes from negative 1 to 1, when you start flipping those, you end up getting larger and larger answers. So for example, flipping 1/2 gives you 2. Flipping a third gives you 3, and so on. So that's why there's no values between negative 1 and 1. Next thing we'll look at is go on and graph the y equals secant of x, which remember is the reciprocal of cosine of x. So put y1 equals 1 divided by cosine of x. Number 9 is graphing the tangent of x. And tangent of x is not a reciprocal trig function, but it has asymptotes. So that's why I put it on here. And then while you have tangent of x in there, you can look at these limit questions. Remember that limit as x approaches 0 from the right of tangent of x means that as you trace tangent of x coming to the right side of 0, where is your function going? So this goes back to earlier content where I introduced the idea of limits. And then number 10, cotangent of x, make sure you graph that as 1 over tangent of x, or remember the tangent of x is sine over cosine, so you can flip that for cotangent of x and say y equals cosine of x divided by sine of x. So go through and do that and answer where the asymptotes are, and then what values are restricted, and then the range for each of those. And I'll put the answers up. Here are the solutions for the y equals secant of x. These will have vertical asymptotes when the cosine of x equals 0, which happens at these values on the given interval. So in general, what values are restricted from the domain of y equals secant of x? Well, this is a little trickier to write than the one for cosecant, because here, if we just start at pi over 2, we have to add pi or subtract pi. So if you think about it in terms of degrees, this is 90 and 270. So if you start at 90 and add 180 degrees, that'll get you to 270. If you subtract 180 from 90, you get negative 90. Okay, so in terms of pi's, you're adding or subtracting n times pi, where n is any integer. So you start at pi over 2 and then add or subtract n pi, where n is an integer. And I do want to point out that a lot of times you see, instead of just plus n pi, you'll see like plus or minus. You'll see plus or minus there, n times pi. Same idea. Okay, and then the range is the same as the cosecant function, negative infinity to negative 1, and then union 1 to infinity. And then for the tangent of x, okay, this is where we get the vertical asymptote. Notice these are the same place where the secant had vertical asymptotes, because that's where the cosine of theta equals 0. So that's the same asymptotes as secant. The range on tangent is negative infinity to infinity. And then when you look at the limit questions, as you approach the tangent curve from the right-hand side of 0, it goes to 0. So it goes right through that point, 0, 0. And then as you approach pi over 2, or 90 degrees from the right-hand side, it's getting lower and lower, closer to that vertical asymptote, get to negative infinity. And then you can look at the rest of the answers there. And then for the cotangent curve, this is now cosine divided by sine of x. So these will be the same asymptotes as the cosecant curve. So x equals n times pi, where n is any integer. The range of cotangent is the same as the range for tangent. I just didn't write it. Negative infinity to infinity. So that's the reciprocal trig. And again, just using your calculator to graph them is the best thing to do.